take the shape of a circle because of the symmetry along the x and y axis. You see, let's say this circle now, and because of the way it is, we can easily say that the moment of inertia about the x-axis is equal to moment of inertia about the y-axis. You understand? So let's take it y-x-axis. And now, I take this small part, and I want to find the moment of inertia of this one about this y-axis. So this is x. This one will be delta x. Let's say it has, so the area will be 2y delta x. Area will be equal to 2y delta x. You know this place to this place is y. And now, since I know the area, let's say the thickness is equal to t. Thickness is equal to t. So volume will be equal to 2y delta x. Let's say rho is the density. So mass will be equal to 2 rho Ty delta x. Then the second moment about y axis. Second moment of streak about y axis will be equal to 2 rho Ty delta x times x squared times x squared. So if you give me 2 rho y x squared delta x. So that's the second moment of the streak about the y axis. Now, for the the radius of the circle is r, and from this place to this place will be r. From this place to this place will be r, but we take it as minus r. So for the whole, so moment of inertia of the whole will be equal to minus r for 2 rho y x squared dx. Y x squared dx. Now, if you look at this, it is better because I can say that y is equal to r squared minus x squared. You understand? So it is better I made it into parametric equation. Here y will be equal to, from this shape, I can see that y will be equal to r sin theta, and x will be equal to r cos theta. You can pick it. Y is r sin theta, x equal to r cos theta. So what is the x? Will be equal to r sin theta. That is minus r sin theta. Now, so I can write this as this I now. I can make it to be equal to 2 rho t from r to minus r. From r to minus r. What is y? R sin theta. What is x? R cos theta. So we have square of it. What is this one too? Minus r sin theta d theta. So let me write it out here. I have y 2 rho t r minus r. How many r do I have? R is over 4. How many sin do I have? Sin square theta. So I want to change this limit. We know that x equals to r cos theta. So when x is equal to r, cos theta will be equal to 1. So theta will be equal to 0. When x equals to minus r, cos theta should be equal to minus 1. And at that time, theta will be equal to pi. I think it's pi. Yeah, pi. It's pi. So I can now write it like this. So I y will be equal to minus 2 rho t from 0 to pi r raised to the power 4 sine square theta or square theta. So everything is now very sensible. So which I can now rho t r raised to the power 4 from pi to 0 sine square theta sine theta cos theta all square theta. So it is now looking very manageable now. Now I can now make it to be Iyy equals 2 rho t r raised to the power 4 from pi to 0. You know sine theta cos theta is equal to half sine 2 theta. You know 2 sine theta cos theta is equal to sine 2 theta. Therefore sine theta cos theta is equal to sine 2 theta over 2. So I'm going to have this as sine 2 theta over 2 all squared theta. So I can write it as this: 2 rho t r raised to the power 4 pi 0 sine 2 theta over 2 all squared theta. So 2 rho t r raised to the power 4 pi 0 sine square 2 theta over 4. And you know when we have it like this, sine square theta, for ease, we have to change it to be in terms of cos double of this angle. You see, you know, sine square 2 theta will be equal to 1 minus cos 4 theta over 2. So I'm going to bring this into this equation. So Iyy and I'll do 2 rho t r raised to the power 4 pi. Let's bring this for outside. So 1 minus cos 4 theta over 2. So it has now really made sense for us. So Iyy will be equal to 2 rho t r raised to the power 4 over 4 into theta. Okay, let me bring this to outside. Times 2 here. Minus sine 4 theta over 4 from pi to 0. So this is going to cut this. So rho t r raised to the power 4 over 4 into theta minus sine 4 theta over 4 from pi to 0. So this will give me rho t r raised to the power 4 over 4 pi. When we have sine 4 pi, that will be 0 over 4 into 0 sine 4 0 equal to 0. So at the end of the day, my Iyy will be equal to rho t r what you have said, IYY is equal to IXX for circle. IYY is equal to IXX. So simple. So we have gotten it to be FR squared over 4. Now I will have to do it about the center, about a perpendicular axis that passes through the middle. And from there we will get another theorem, the perpendicular axis theorem. Let's go. Now let's look at this shape. You know, I can find the moment of inertia about the axis that is perpendicular to the surface area. And if I should do that, taking strip like this and the distance like this, it will not work. Because the distance of this place is different from the distance of this place, is different from the distance of this place. So the easiest and cheapest way to undo it is to make a circular ring and then work with that around it. So you can see now. So the distance here is now making sense. All of them, the total distance is uniform. So this is x. And the real distance from the center for this one is r. You understand? So what is the area of this shape now? Let's call that one, because this place is 2 by r. This place is round. So area of strip is equal to 2 by x delta x for that place. So let's W is the mass per unit area. Since you have taken the thickness to be, minute, or we assume that the thickness is uniform. That is it. So W. So mass of strip is equal to 2 pi W x. So for the moment of inertia of strip is equal to, we take square of this distance, x squared times 2 pi W x delta x, which is 2 pi W x cubed delta x. Now, we have gotten that of the strip. So total mass is equal to 2 pi W x dx from 0 to r. And that's going to give us 2 pi W r squared over 2. So you can see this is W pi r squared. That is simple. That's normal area that we get in mathematics. This time around, let's now calculate our total moment of inertia. It's going to be 2 pi W x cubed. Yes. Which is 2 pi W what's it called? X raised to the power 4 over 4. So this one. So if we bring this one here now. Oh, sorry, this one will be R, sorry. So if we bring W by R squared here, it's going to be N R squared over 2. So you can see N is W by R squared. So factorizing to be R squared times R squared here. So that is our I for this circular shape. Now, that's the standard result for this circular shape. We want to get something about perpendicular axis. The previous one we talked about parallel axis. That is certain distance from it. But now let's look at something about the perpendicular axis. It's a very simple thing to talk about. Now, look at this. We have a shape like this. We have the x-axis, we have the y-axis, x-axis. You understand? And if you look at it, we have the z-axis that bore in through this place. Let's just place it like this. inertia of this from this place. That will be dn. Let's say this is y, this is x, and this is from z. So the moment of inertia about y, about moment of inertia about x axis is equal to dn times y squared. Moment of inertia about y axis is equal to dn times x squared. Moment of inertia about z axis is equal to dn times z squared. But if you look at it, z squared is equal to x squared plus y squared. X squared plus y squared. So it means that delta n z squared is equal to delta n x squared plus delta n y squared. So if you want to find the full moment of inertia about z squared, so we are going to have it like this: summation dn z squared is equal to summation dn x squared plus summation dn y squared. What does that imply? It means that the moment of inertia about the perpendicular axis will be equal to the sum of the moment of inertia about this other part intersecting at this perpendicular point. So it's going to be I xx plus I y y. So what is, like the last example we did, it is a circular shape, and I found the moment of inertia about this point, which was n r squared over 2, that is I z z. But if you look at it, it is a regular shape, and I xx will be equal to I y y, looking at the symmetry of the shape. Therefore, I xx plus I y y should be equal to 2I xx, which is also equal to 2I y y, which should be m r squared over. You understand? So I xx will be equal to I y y, which should be m r squared over 4. So what does it imply? If I know the moment of inertia about this axis, and I know the moment of inertia about this axis, I can find the moment of inertia about the points about that axis that pass through perpendicular through the intersection of the two axes. That's what it implies. So I hope you see. So this one is m r squared over 4 here. So that is it. We will still apply all these things in the future, but I'm glad that I have introduced them to you now. Thank you very much. So we'll see in the next class. Kindly subscribe, share, comment, follow, and do whatever you believe can assist in propagating this knowledge. I appreciate you, and I thank you for all the support you have given me. Thank you very much.